Hello, pre-algebra. We are transitioning in our geometry unit from two-dimensional shapes to three-dimensional shapes. And these three-dimensional shapes have some special vocabulary that go with them. So here will be one page of notes where you can just write down all the definitions. If you are somebody who struggles with vocab, you might want to make a Quizlet or some flashcards over these to just constantly review them to make sure you know what they all are and you can speak of them naturally. A face is a flat surface on a three-dimensional shape. So those are like the sides that fold up, like on a cereal box, the front, the back, the top, the bottom. Those are all faces of the box. A prism is what a cereal box would be. It's a 3D object that has two congruent and parallel bases. And those bases actually are faces as well. So congruent, in case you don't remember what that means same size and shape. And then a parallel end, like we've been talking about with trapezoids, have two parallel sides. Those are that if they continued on, they would never intersect. And the parallel parts are the parts that you can tell what the bases are. It does not necessarily mean the bottom, because you can turn and rotate that prism to be facing any way. If the parallel parts are rectangles, like on a cereal box, top and bottom are parallel, front and back are parallel, left and right are parallel, then that is a rectangular prism because the parallel parts are rectangles. If you know like what a Toblerone box looks like, that's the kind of candy, the ends are triangles that are parallel to each other. This is the parallel part of triangles. It's called a triangular prism, and you name it based on the parallel parts. A pyramid, if you guys remember your study of Egypt in 6th grade social studies, you'll be able to picture what the pyramids are. On pyramids, they have a whole bunch of triangular faces on the sides, but those triangles are not parallel to each other. In fact, they all come together to meet at a point at the top, and so that top point is called a vertex. So the triangles all meet together at the top, and the vertex, which is our next word down here, that's a point where they meet or intersect. So that's why there's a sharp point at the top of the pyramid. Prisms and pyramids are named based on the base. So they're named for the base, meaning if the base is a triangle, it's a triangular prism or a triangular pyramid. If the base is a square, it's a square pyramid or a square prism. If it is a rectangle, it's a rectangular prism or rectangular pyramid. Those are the types we're studying this year, but it could be any shape. You could have a hexagon base, so it could be a hexagonal prism or a hexagonal pyramid. Any shape there at the end. So we have the vertex, which are points. The edge is a line segment, or you might think of it like where it folds over to make the box or to make the section or the 3D shape that you have. So I'm going to kind of remind you, it's kind of like the fold. And that's where the faces intersect. So we have some names of shapes that we're looking at here, and then we have some parts of shapes, and they should have probably been grouped better. But a prism is a name, a pyramid is a name, and then our last two we're going to look at are cylinder and our cone. Those are names of shapes, versus the face, the vertex, and the edge are the parts that could be on any of these shapes. Cylinder, if you think of it like a can, like a canned good you have, it's kind of like a prism in that it has two parallel parts, except for those parallel and congruent parts happen to be circles. So they have circular bases. So instead of a rectangular prism, it can be a circular cylinder. Same thing with a cone. It has a circular base, and then they come together to make a single vertex at the top. So it's kind of like a pyramid, but instead of resting on a square or a triangle or rectangle, it rests on a circle. So let's see if you understand how to recognize the 3D objects. Right now, push pause on the video and write down what you think the name of each of these 3D objects. And the 3D objects here with straight sides are called polyhedrons, so the ones on the left. And be specific as you can, and then come back and check yourself. Here are the answers. B, cone. You probably recognize that like an ice cream cone. That one's just turned upside down to what you're used to. And D, cylinder. Those do not have any specifics you have to put with them because they already assume that you have circular bases when you name those shapes. However, on A and C, you have to name them by the base. Please notice that on A, This is not a triangular pyramid because of all the triangles that come up to the point at the top. It's triangular because the base is a triangle. This part right here that it's resting on. Because every single pyramid has these triangles that are on the side that would come up to make the vertex. So we just name them based on the base. On C, the rectangular prism, it does happen to be resting in a rectangle on the bottom and top as the bases that are parallel. However, it does not have to be. We could have said, well, the front and the back rectangle are the bases because they're parallel, also incongruent. Or we could have said over here, the left and the right. So as long as you find parallel parts, you see what shapes they are, that's what kind of prism it is. Every prism has rectangles in it. So that's why you have to look for where are the parallel parts, and that's the name of it. Right here is an example of a prism that has rectangles in it, but this is not a rectangular prism because all of these rectangles intersect here at an edge. They touch. The parts that are parallel that never intersect are the ends here that are triangles, which is why this is called a triangular prism. The parallel parts are the bases, and since our bases are triangles, we are going to name them with the 3 letters or the 3 vertices points that make those bases. So right here, A connects to B, which connects to E. A, B, E is one of the bases. You just put them all together like that to show that they're connected all together. And the base that it's parallel to, F, connects to C, which connects to D. So F, C, D. The order that you name the letters don't matter. I would have been allowed to say D, F, C if I wanted, because they are all connected. Or I could have said B, E, A. Just pick something and make sure you're going with what it's connected to, not a random point somewhere else on the shape. So for example, when we're doing our faces, remember faces mean flat surfaces. If you need to give yourself a reminder, the bases, you're looking for the parallel parts. And the faces, you're looking for the other flat surfaces. If we trace a face, like this one that's resting on the bottom, this rectangle, I connected the A to the F to the D to the E is how I just connected that rectangle. I could have also said A, E, D, F. Or I could have started with D, F, A, E. I cannot write D, A, E, F, because the D is not actually connected to the A on the shape. So when you list it out, list them in the order that they're connected. Okay, let's find another face. There's a rectangle that's standing up vertically in the back, B, A, F, C. Back there, if you can see that rectangle, so I'm going to write that, B, A, F, C. And then there's this one in the front, B, E, D, C, that's tilted to connect this bottom one to that back one. So I'll write that down, B, E, D, C. So when you're naming a face or a flat surface, you just need to name the letters for the corners that join them. Those corners are called your vertices. So while we're talking about those anyways, let's jump down and fill in our vertices. Remember, those are just the points. So those are single spots on their own. So here's an E spot, here's a D spot, C, B, A, and F. All those little individual points that make corners. So I'm just going to list them all out. There was an A, an E, a D, an F, a C, and a B. And they can be named in any order, because we're not talking about connecting anything to make a shape. It's just all the individual points around the shape. And then do you remember what your edges were? Edges are your segments, like your line segments, or your folds. However you want to think of that. So right here, this back segment right here, that's an edge, because that's where the rectangle standing up and the rectangle laying down would fold. So I'm going to say that one of my edges is A to F, comma, and I have to find another one. Here's a fold where the triangle folds up, like if it was laying down flat, it would fold up from this rectangle. So I have A to E. And then here along the front, the E to the D is where this rectangle in the front could fold and lay flat, or it wraps up to connect it. So E to D. And on the other side of that rectangle, I see D to F is another fold where this triangle right here can fold down and up based on that rectangle. So D to F. But that's not all. Everywhere where you see like a line that you could trace, those are all segments as well. So these are all edges. So AB and EB would be edges to finish up that triangle. And then here I have BC and CE, which would finish up the rectangle in the back. And then finally, to finish up this triangle, I have C to the D. So you want to be careful that you've included all of your parts. And since these are line segments, we name them by drawing a little line segment above them. And that shows the reader that it's just 2 points connected to make a little line segment. All right, review this part of the video if you need again to practice how to name and how to recognize those pieces, and you will do a review over it tomorrow in class.